Taint analysis has been around a while. It's really just tracking untrusted data through the system to see how it is used, to see if it is used in unsafe ways. Aspect-oriented programming does not replace object-oriented programming or any of the other things you've learned. All of your design technologies still work. It will, however, probably make you a better object-oriented programmer because it enforces a certain amount of discipline in how you design things, how you name things, how you put the components together, how you create your methods, how you design your objects so that they are cohesive. All of the things you've learned about design skills, aspect-oriented programming will help emphasize those things. Aspect-oriented programming looks at cross-cutting concerns, those things that apply across the whole system, those things that are related to logging or tracing or possibly some debugging, authorization, authentication. We'll take a look at a couple of examples here and how it looks in code to see what that means to you and some of the powerful abilities it gives you. It also adds a little bit of vocabulary, aspects, advice, join points, and point cuts. We'll go through each of those one by one so you'll see exactly how they work. I won't be able to tell you everything about them because it's a deep topic and there's whole books written on it and lots of work. Aspects actually are not new. They've been around since the mid-90s. Aspect-oriented programming, those concepts have been around a while. They realized that object-oriented programming didn't solve cross-cutting concerns. If you've got a system with 50 classes in it and you need logging, you probably have 30 or 40 classes that have some kind of logging code in them. How do you get that out of those classes? How do you put it somewhere where that logging can be in one place and none of the classes even refer to logging at all? That is what a cross-cutting concern is. It's when you have a piece of logic or chunk of logic that really belongs by itself, but how do you have a logging object that you don't have to keep referring back to? What do you do with it? So authentication authorization is the same thing. Aspect-oriented programming is not specific to a particular programming language either. There is AspectJ, which is the aspects on top of Java. So if you have a Java system, you can go in today, add aspects to it, and gain a lot of the benefits of aspect-oriented programming. There's even aspect-oriented PHP. I did a little project just for, I had a little PHP website where I wanted to add authorization and authentication to it. I was able to do that without touching the original PHP source code, just by adding aspects to it. This is one of the very powerful features of aspect-oriented programming. Changing how the program runs, adding features to it across the board without changing the original source code. Letting the compiler do the work for you. That's what this aspect-oriented programming does. You're going to get code that's been tangled up in all of your classes before. And you're going to get that out of those classes, put them into aspects, which are analogous to classes themselves, but they are different because the compiler is going to say, I'm going to take this piece of code and I'm going to put it here, 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 and here. We'll look at examples. You'll see exactly how it works. So here we have just a very small, simple little routine. It's just to buy an item. It's going to look up the amount of the item, how much it costs. If it's less, the cost is less than 0 or equal to 0, it's going to throw an exception because, well, you shouldn't let somebody get something for free, hopefully. And then it's going to charge the credit card. Very simple. That is before adding our cross-cutting concerns. Maybe we want to have some authorization before they execute this charge. Maybe we need to do some logging. Maybe we need to handle the exceptions that come back from the charge card. If the charge card function at the bottom there, it actually works, yep. That charge card function, if it throws an exception, maybe we need to handle that. There's a lot of things we can do here. What if we need to do database transactions? Well, after adding all these cross-cutting concerns, that's what the code looks like. How many of you have code that looks like this? All over. I have done about 12 years worth of expert witness work where I've analyzed millions of lines of code for legal cases. This is standard looking code, and it's a pain to look through if you have to analyze it. It's awful. But where's the core logic in there? Well, it's right back to what we have here. This is what we really care about. Let's say by item is here inside of its own class. We don't want logging and database and other stuff to start polluting our class. We want our class to be nice and encapsulated and be single purpose. Let it do its job. Instead, we have to add things like up here at the top, we have our is user authorized. If it's not, then we have to log it, and we want to throw an exception. We have to look up the item. If it's an invalid item, we want to log that too. Before we charge a credit card, we want to start a transaction because we discover that the original programmer didn't have that logging or the correct transaction boundary set in the charge card function. And if it fails, we want to handle that exception. So how can we get all of this tangled code untangled and out of there? We need to get that out. So let's talk about the aspect-oriented programming, some of the concepts, so we can see how that code can be extracted and not pollute our original class. So a join point is the location of interest in your code where you might want to change the functionality. You get join points for free. You don't do anything to get join points. They are already in your code, ready to go. If you've written a Java program, you've got join points because you come right back here. You have a join point here at by item, the function itself. You have a join point at the call to look up amount. You have a join point at the exception. You have a join point at the call to charge card. All of these are predefined for you. So you get them for free. You do nothing. This is great because now we can figure out what we have to do. We have to decide which ones of these are of real interest to us. So that brings us to the point cuts. The point cuts say, I'm interested in join point A, B, or C. And a point cut can apply across the whole system. So it's like a wildcard, and it uses wildcard technology, or not technology, terminology to describe it. So this point cut here says charge PC. It's got a name of charge point cut. And it's a point cut that says, I want you to find all of the functions that are public and that have a void, no return value, and begin with the word charge. So charge star is a wildcard, so find all the functions in my whole system that match that signature. And it's going to make a list of all those points in your code that match that signature so that you can do something with them. So we've got our join points, which we get for free. We've got a very simple mechanism, which is the point cut to say, I'm interested in just these particular join points. I'm only interested in a few. I don't want to change everything in the system, but I am interested in a few things. Advice, then, is a little code snippet that runs at those join points that are specified by the point cuts. There are three types of advice. There's before, after, and around. Going back to here, we have a charge card, which I mentioned before was one of our join points. You could set up some advice, which is a little code snippet. You can set up one code snippet that runs before the call to charge card. You can set up another little code snippet that runs after the call to charge card returns. You can set up a little code snippet that says, I want to handle any exceptions after the call to charge card. If charge card throws an exception, I want to handle it. I can also even do a round advice. A round advice isn't really a round. A round is really replace. So I can even say, I don't like anything about that charge card function. I want to just replace it. Or maybe I want to run some code before it runs and then optionally run the original code and then do something else after. The around advice lets you do that. It's a lot more complex and more powerful kind of a function. We can eliminate all of that extra tangled code by using just these three simple items. Join points, which we get for free. Point cuts to specify which join points we're interested in. And advice, which is our code snippets that we are going to run before, after, or around each one of those join points. By the way, any questions you have, ask them immediately, because I don't know how much time we'll have at the end. So, and I just speak out loud, and I'll repeat your question so it will show up on the video. I know you've been trained throughout the week to go to the mic, but just yell it out, I'm good. So aspects then are analogous to classes. They take the join points and the advice and they package them up in a nice, neat package, similar to how a class packages up all of your properties and your methods into a nice, neat package, so it's encapsulated. We want to put all of our logging into one aspect. We want to put our database overhead, the transaction management, into an aspect. We want to put our authorization into an aspect. And then we want to say, I want to do these things at specific join points by using the point cuts. And the process of doing that is weaving, and the compiler takes care of all the work of putting your logging in the right places. You no longer have to do that. You have to figure out where it is, and because it's using wildcards, you're going to have to be doing a certain amount of consistency in your naming. So here's the database aspect. This aspect has its own instance variables. It can do that too. This is not by the way, none of this is compiled code. It's for demonstrations only, but you get the idea. So we've got database instance variable, which can be used anytime the aspect needs to access it. We've got a point cut that says, I want to change how the calls to charge card throughout the system, the charge card method in the charge card class, I want to change it throughout the system so that it does what I want it to do, or I need to add some additional functionality. In this case, we know we need to start the transaction before the call. And so we have here a before advice. It's a little weird to look at first because advice does not have a name. Advice just has the word before, and it has the name of the point cut that says everywhere. So it refers back to the point cut up above that says, here's all the places I want that before advice to run. Remember, advice is just a little code snippet. In this case, that code snippet is just db start transaction. And then it changes the logic anywhere in the system that is calling charge card. It's going to start a transaction first. Well, after return successfully, then there is this after returning advice. After returning says if it succeeds, in other words, if an exception was not thrown, I want to do something else. In this case, I want to commit the transaction. So I'm going to commit the transaction because I know the charge card actually succeeded. If it failed, I'm going to run after throwing, and it even can keep track of what the exception is. And if it throws an exception, I'm going to roll back the transaction. I'm going to void that transaction so that it doesn't go into the database. There's nothing in there. We don't want the database to do its default, which is usually just very incremental. Every time you hit the database to do an insert or a charge, it actually makes a change to the database. We want to roll back those changes. That's a lot easier than having that tangled up inside of all this. We've essentially gotten much closer now back to our ideal of letting that method do just what it's supposed to be doing, nothing more. Okay, let's go back. Now we have another one. We've taken care of our database stuff now. What about our logging? We had the logging, which there were four logging statements. Three of them were in, let's go back and look at it. Three of them were because of exceptions that were about to be thrown. And one last one was because we want to keep track of any charges that succeeded. We need to keep an audit trail of that, so we're going to log that. So we come back to our logging. We have a logging aspect, a little logger aspect. This one has 2 point cuts in it. It says, I'm going to use logging wherever somebody makes a call to buy item. And I'm also going to have another point cut that says, I also want to change the logic anywhere somebody, some part of the code calls creditcard.chargecard. Notice that point cut is the same in both places. So we've got multiple pieces of advice operating at the same join point. In fact, here we have 3 all using the same point cut, charge credit in each case. And so we can do multiple things at each join point. We can have multiple aspects that work at each join point. As you can imagine, this is easy for us to do as people. It's a pain in the it's a really pain in the butt for the compiler, but I'd rather have the compiler do it for me than have me do it. I was born to be a lazy programmer. I've been a developer since, well, about 40 years. So it's been quite a while. And this particular topic, aspect-oriented programming, has me more excited than any other technology I've seen in a long, long time when it comes to programming, because it works with object-oriented programming to make it better. It doesn't replace it. It works to make it better. It takes all that stuff, that grunge that we used to put in the objects, and it puts it into aspects separately. So our log here, we have one that's a by-item PC for by-item point cut. In this case, anytime by-item throws an exception, I want to log that exception. So it says after throwing an exception for by-item PC, I'm going to log it. So those 4 places, or 3 places in the original code where I was throwing an exception and logging it at the same time, now I'm just throwing the exception, and it's going to catch that and log every single one of them. Somebody goes in and modifies the code, has a 4th exception get thrown, this will still catch it. This works really, really well for maintenance too, because if somebody adds a new call to by item, it's still going to get logged. Any exceptions that it throws are still going to get logged. You don't have to go in and make changes all throughout your code. If your authorization technique changes, you're not going to go back into each class, each method that checks the authorization, because the authorization doesn't exist there anymore. It's in an aspect. After returning successfully from charge card, remember we've got our charge card here, we've got our point cut here. So after returning from that charge card, if it succeeded, it's going to log that it succeeded. We are just with those 2, we're almost back to this point here. Now I didn't display this one here because it's pretty much more of the same, but I could use the exact same technique to get rid of the user authorized out of that method and put it into an aspect. I could then use point cuts to say I want to do that authorization logic at all the places where I want to do that authorization logic after the fact. If you use standard naming standards and you use wildcards in your point cuts, it's going to make it easier when you modify the code, because it's going to access those. It's going to weave that code into that new function just the way you expect it to. Okay. Questions so far about how that works?
Do your point cuts have names, and can you use the function inside point cut and have a point cut there so that your aspects have aspects?
Okay, so the question is, do point cuts have names? Point cuts do have names. This point cut has the name charge credit. And it's essentially, if you think of this, what's on the right-hand side says that it's a call with public int creditcard.chargecard. In this case, it says I'm going to match the signature of any method in the credit card class with the charge card method. Now, there could be wildcards at any point here. I could match anything that's private or public. I could match anything that returns any value. It could be an integer, it could be a string, it could be void. Think of it, there's a couple of ways of thinking about these point cuts. You can think of them if you're into a database kind of a system. You're doing a select star from application where your method name is like this thing on the right. Or you could do a thing, if you're doing text analysis, you could do it with grep. I'm grepping for anything in the whole system that matches chargecard.chargecard. This is really powerful because you're making the compiler do all that work for you. You're not going through and finding all these calls. You're letting the compiler do this. And you had another question.
Can you have an aspect of a point cut? If I say
Okay.
match anything that's charged star and it's a point cut, you can find this and have aspects modifying your aspects.
So the question is, can you have an aspect of a point cut?
Yeah,
Not,
cursive.
yeah, not as such. What you have is the point cuts to specify the places of interest. These are the join points that I want to process. So these are the points in the code I want to process. So in this case, we know we want to look at anywhere there's an exception thrown. We want to look at where functions are being called. Those are the ones that are of interest. We're only interested in charge card and the exceptions in this particular example, so we can do our logging and so that we can do our database transactions and user authorization. Does that answer the question? You can, by the way, aspects will also, there's so many features about aspects, and I don't want to get into that deep because it's kind of outside the scope of the presentation. But the aspects can inherit from other aspects too. But it is a little weird sometimes when people first see this before and after stuff and it doesn't have a name. So just be aware that those things don't have names. The advice does not have a name. But think of them just like little code snippets. I want to put that little piece of code here, here, here. And it makes a little bit more sense. I want to put it before the join point, after the join point, or I want to replace the join point entirely. Any more questions before I move on to the taint analysis? Okay. Okay, taint analysis isn't exactly new. Most of the vendors over here that are doing some kind of vulnerability checking are using some form of taint analysis. HP's Fortify does, I know Veracode does, and I've heard a few others, and there's been a couple of presentations that also talked a little bit about taint analysis. I'm just going to go through it quickly to show so that you have the right background to see how taint analysis matches up with aspect-oriented programming. Tainted data is any data that comes from any untrusted source. You know, users, databases, files. Do you really trust all the data that's in the files that are input to your application? Think of a Word program, you know, the Microsoft Word. It certainly can't trust the files that are coming in. Nobody's seen malware in a Word document, right?
Not in minutes.
Not in minutes, yeah. Exactly. So basically, taint analysis then is following this untrusted data through the application to see how it gets used and reporting on places where it gets used unsafely. The problem is that because aspect-oriented programming changes the control flow because you're injecting code into the original objects, you don't have taint analysis because it just blows the taint analysis model out of the water. So there's a few rules you have to follow when you're doing taint analysis. A variable is tainted if it comes from an untrusted source or if it is assigned, if it receives its value based on another untrusted variable. And it's transitive, which just means that if A is tainted, it gets assigned to B, B gets assigned to C, then C is also tainted. It just means you have to follow it all the way along. It also means that if you are passing tainted values as parameters into functions, that tainted status has to follow into the function that's being called. And any return values may also be tainted based on the kind of calculations that are going on inside that function. And advice, here's the problem with advice though. What if somebody gets a little bit too ambitious and they change their advice so that it changes a variable that has previously been sanitized and has been cleaned up and been validated so that it is not? Or maybe vice versa. We have to know that so that we can give the proper report to the programmer, to the developer, so he can go back and make the proper changes to his code. So we've got the input coming in. Now that data is being used in some way. There's a sanitization process that can be applied to that variable that will clean it up. These functions are trusted functions. We tell the system, these are our trusted functions, and things we come back out of those functions are clean. They are no longer tainted, so you can clean things up. There's a whole body of literature, a whole body of research that's about deciding whether or not these sanitization functions are correct or not. That is way outside the scope of what we're covering here. But we just know that we have a sanitization function we can use of some kind. So then, after that, subsequent uses of the variable are not tainted anymore. We can use it safely. The problems arise when tainted values are copied to sensitive sinks, whether that's a database for persistent cross-site scripting, whether it's a web page for reflected cross-site scripting, or here's a couple of cases that most people forget, because we are so focused on web applications and the data that gets displayed back to the user or that gets used to query the database. Seems like we're totally focused on SQL injection or cross-site scripting, but there's other logic problems that happen. Let's say you've got a piece of data, and I've heard so many programmers say, well, I'm just converting this value to an integer, so I have no problems with this data. That's wrong. That data might be getting used as the object of an if statement, which means your attacker now has control over what happens, which branch of that if statement it takes, or how many times it executes a loop, or if it executes a loop at all. You're giving the attacker a certain amount of control. So there's not just sensitive sinks, but there's also a control factor that enters in where you have to be very careful not to allow tainted data to be used to make decisions in the code. Something very important to remember. So here are the items we need for doing a valid taint analysis. We need a list of untrusted sources. That's going to be context sensitive. It depends on the application. If it's a web application, you've got different untrusted sources than if it's a word processor or any other kind of application. You've got a financial application. Quicken is going to have a different set of sources than a web application as well. All these things, so you need to know what those are. We've got a list of trusted sanitization routines. We've got a list of sensitive sinks. In addition, we also know we have to be careful of just the control paths, the ifs and the loops. Are they being used in those locations? We also need to know the control flow. We need to know the data flow. The data is starting up here, it's going through here, 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 and here, and all the way down to the bottom, so that we can find out, is it being sanitized before it gets used in a sensitive way? Well, this is just, I'm not going to go into detail on this slide, just so you know. This comes from a paper by Sue and Roundtev in 2008. This has been around a little while. They actually created a nice way of normalizing the advice being woven into an application, into a method, so that we can see all of the input going in, we can see what all the advice is doing. Advice, I showed you how it can be multiple pieces of advice, can apply to each joint point, so it normalizes all that, gets them in the right order. There are ways, by the way, in aspect-oriented programming to specify the precedence, so which advice should come first. Should it be the database or should it be the logging? How does the compiler do its work to get the advice woven in? So how does the compiler do the weaving is the question. It's actually multiple answers, unfortunately. What it will usually do is in the process of compiling, it will compile normally, it will compile the Java class first. Then it will look inside the bytecode and it will modify the bytecode and create a new chunk of bytecode for that method. There are ways of doing it at runtime as well. So you can do runtime weaving. When I first saw this, my first thought was, holy patching Batman. This is, I'm patching stuff. I'm replacing chunks of code. This seems dangerous. This is, doesn't it? Seems very dangerous. Yeah, if you replace bytecode, all heck can break loose. Exactly. Yeah. So, no. And that's one of my recommendations at the end, is you have to use this in a very disciplined manner. You're using it for the things it was really intended for, which is the cross-cutting concerns. You're not going to use it for your base logic. And you're sure as heck not going to let the bad guy, let the attacker start using aspects on your code either. Because now you've got source code that doesn't change, but the aspects are changing it. Ooh. Yeah. It's another reason why you need to do your file integrity checks all the time for your for your Java libraries, for your jars. Make sure that you're checking that, because somebody could have put an aspect on there. You might not be able to see it because it looks like the functionality looks the same to you. Yeah, crazy stuff. But you can see, if you start adding some of this advice nesting stuff, it gets to be kind of a crazy mess up there. It looks like a spider's web of a mess. Luckily, these guys did some really good work, and so they created a tool called Ajana. It's a library. It's a Java library. And it creates what is called an inter-procedural control flow graph, and I'm just going to call it an ICFG from here on out. That will basically give you all of these dependencies and say, here are the order that things are going to be executed in. Here are the pieces of data that are available at each point. The logic really is you just start with the untrusted sources. I don't care about all the safe stuff. So I'm going to filter out all the safe stuff, and I don't care about that. I'm only going to be looking at data that starts with an untrusted source, follows that data wherever it needs to go until it's either been sanitized, in which case I'm not interested in it anymore because now it's safe, or the last use of the data. Hopefully it hasn't been used in some unsafe manner. If it has, I'm going to report it. If it gets used in an unsafe manner, if it goes to a web page, if it goes to any of our sensitive syncs that we have that list of, then that is going to be reported back to the developer so he can go in and fix the code. So he can make sure his aspect isn't screwing up the original code. The idea is that the aspect is making changes. Maybe it changed untainted data, clean data, back to tainted. We don't know. So we need to be able to detect that. We need to know if tainted data became clean. Maybe we wrote our aspects for that very purpose, to clean up the application. We came into a system, we're not allowed to change the source code, but we have to patch it. Aspects are a great way to do this because you can go in and say, I'm going to sanitize the data before the original application ever gets control of it, before it ever starts to process that data. Very, very cool stuff. It's a lot of powerful things we can do. It works because that ICFG contains the data we need. I am so glad that they did this, because if they hadn't, then doing the taint analysis would have been a royal pain. Now this is a much more generic, much more orderly, comprehensive, I should say, processing of the data, of the program. But with that gives us the tools we need to do our taint analysis. All variables are known. Now this is a static process. There are still dynamic tainting that can be used. Sometimes there are things you can't figure out during static analysis. John Holt presented yesterday on some dynamic analysis using actually changing the runtime of the Java virtual machine to do dynamic tainting analysis, which is very cool. The two are complementary. You really should have both of them because you want to have as clean a source code as you can, and you want to have that extra backup of having some dynamic tainting to back you up. Takeaways. Aspects are cool. Anybody watch Doctor Who? Everything's cool. Aspects are cool. Taint analysis can be applied to AOP. It works very, very well. And it's also pretty much necessary that you do it automated. I don't see any way that you could really do it manually. It's really tough to do that. Also, when using aspects, be aware you could be introducing additional vulnerabilities. My feeling is so far, in my experience, is that if you are disciplined about it and you use it just for the cross-cutting capabilities that it's meant to be used for, you're much less likely to introduce additional vulnerabilities. Unfortunately, we've seen this with object-oriented, with OOP, object-oriented programming and everything else we've ever seen. Programmers will abuse the tools they have. It's just the way it is. And in the millions of lines of code I've looked at, I've seen some of the best and some of the worst code I've ever seen in my life. Some of it was just warmed over C code. It was supposed to be C++, but all they did was semi-randomly group things into classes that did whole bunches of things, and then they just stuck the class name : on and says, called it a day. Hey, it's C++. It's not object-oriented. It was just a mess. So we need to be careful with aspects as well. We need to do true aspect-oriented processing. If we can let the aspects help guide our design, we can have a much cleaner design for our individual classes. Let the aspects do what they're good at. Let the objects do what they're good at. And then we have a system that we can maintain. Don't get carried away with aspects and say, oh, I want to solve all my problems with it, because that's not going to work. Any questions? All right. Just a few references. The original paper from Sue and Roundtev, and there's a book by Grodecki. As you can tell, that book is from 2003. We've had aspects for a while. We've had aspect J, aspect C++. You can do a Google on that, and you'll see find aspect C++. AOP PHP is the aspect-oriented PHP. We've got one of the original papers by Gregory Casales, an overview of aspect J, and the aspect J programming guide, which is on the Eclipse website.